Thanks everyone for joining us today. I hope it's a useful session. I won't spend too much time on this, but just a quick introduction to myself, if you're not familiar with me. So I'm responsible for the strategic technology and research at Kemp Technologies under the Office of the CTO. Within the R&D department, work closely with Derek Kiley as well, the VP of Engineering, and Jason Dover, the VP of Product Strategy. I'm the author of Application Experience, a book focused on practical advice for technology and IT leaders. And my background is in network and security technologies, both at Kemp and previous vendors. So really, when we look at the goal for modern IT organizations and people who are looking to manage and enhance the application experience they're providing to their internal stakeholders, external customers, partners, and so on, everything comes down to that old kind of combination of people, process, and technology. What I really want to focus on today is some simple things around the overlap between technology, specifically global site load balancing, and your internal processes, and particularly your security processes and your deployment processes, and how small changes in that using global site load balancing effectively can open up new opportunities, new techniques for both security teams and application or infrastructure teams looking to support their security teams and in certain situations. So that's what we're really going to focus on today. So there's a couple of scenarios that I want to take people through. We'll do a quick introduction into global site load balancing, or GSLB. But then I want to look at how certain security response situations can be enhanced with GSLB. Specifically, we'll look at a technique for blackholing malicious traffic, and we'll also look at a technique for using GSLB to contain an intruder once discovered. We'll talk a little bit about where those things fit into certain processes and situations as well. And then the other thing is looking at, particularly for security teams, if they're really embedded in the deployment process with their application and NetOps teams, or again, if you're an application or NetOps team, things that you could do to benefit your security teams, make them feel confident in your deployments, and how you can reduce risk around security as well as availability there using GSLB. So there'll be the kind of top level things we'll dig into during the talk, and hopefully we'll have plenty of time for any kind of questions as well. Like everything, particularly in security, there's a lot of caveats on this. There's no silver bullets. There's no magic answers that will work in all situations and all times. So I'll also try and call out where certain limitations or caveats are, and it's really about giving you a couple more techniques to put in your toolkit that can help you, because there's so much variation and variability around different incidents. The more opportunity you have and the more tools you have, the better. So that's what it's really about as we go through this. So first, just a really quick introduction to global site load balancing. So again, don't squint too hard on some of the more complex diagrams. I'll break these down as we go through. These are just sort of visual overviews at a high level, and we'll dig into the kind of details as we go. So when we talk about GSLB, we're really looking at the DNS level. We're looking at how we respond to DNS requests for the application FQDN. And this gives us a lot of control and a lot of power over what happens next. It doesn't play any part in the client-server connection. And there's a lot of concepts in GSLB that carry over from traditional load balancing, like scheduling, persistence, and health checks. So if we talk about what it means to operate at the DNS level. What's happening is that the FQDN or the namespace for your application is being delegated to the GSLB device. Again, you don't need to delegate the whole zone. You're just picking FQDN by FQDN which ones the GSLB device is going to be responsible for. And then as DNS requests occur, the certain rules like scheduling, persistence, health checking come into play and allow you to control the responses that are given back. And these responses can be very dynamic, or you can kind of have fixed responses, again, based on all kind of criteria that we'll talk about in a minute. Again, when we talk about this idea that it doesn't have a role in the client-server connection, once that DNS resolution is completed, the user or client connects directly to the application site as it's being resolved. So the GSLB doesn't sit in line in the traffic or anything like that once the application connection is being opened. And this makes it, really quite lightweight in terms of performance, very scalable, and something that is pretty easy to get up and running. And likewise, because it works at the DNS level, you inherit all of the multi-master kind of topology from DNS. It's really easy to add in more devices to scale or get resiliency, to have responses at different locations around the world, or to add or remove GSLB devices from that partnership. And finally, just to kind of go in a little bit more around those load balancing concepts that come over. So the GSLB technologies, they're health checking the sites, again, depending on exactly which kind of vendor you go with or which implementation and how it relates to your server load balancing technologies. You'll get varying degrees of integration there. Obviously within single vendor solutions, like Kemp, you'll get a lot of integration between the server load balancer and the GSLB. If these are mixed vendors, it might be a bit more limited. But essentially, all of the concepts and ideas that you'd be used to from a server load balancer kind of carry over. You can control the scheduling to control how you split traffic between sites, whether that's active-passive, and then a whole combination of active-active based on the geographical location, based on the latency or kind of closest endpoint to the requester, round robin, all kinds of things like that. And likewise, persistence. So once I give a particular result to a particular requester, do I continue to give them the same result, or do I have no persistence and kind of dynamically keep updating? And then also health checking. And again, various levels of complexity on how you health check that a particular site is operational and ready to receive requests. And there are a number of things there that really make this powerful when you start using this in combination. So let's move on to some of the security related scenarios and look at those scenarios where we might have particular types of security incidents. And again, you're kind of looking for as many techniques to respond to those situations as possible, depending on the particulars of the situation. So the first one I want to focus on is DDoS, and obviously this has become more and more of a concern for IT operations and security teams over the last few years. It's become a relatively cheap and effective type of attack, and it's becoming more prominent. So when we talk about denial of service, the whole premise or the whole purpose of this technique is to block legitimate users from accessing the application or the service. And when we talk about a distributed denial of service, it's using multiple hosts, in general, a kind of botnet, a large network of infected and malicious sources to launch a coordinated attack against a specific target. These are, again, fairly easily available for hire and as a service, and there's lots of techniques out there. The reason that denial of service attacks are so prominent and such a concern is it's really a very broad category of attacks, and there's many techniques that are possible there, and there's no single solution to any of them. And that makes it very hard to have a broad protection against all of these. The most effective and kind of dangerous ones are what's known as kind of asynchronous attacks. And this is where a very small number of malicious hosts with a very small amount of traffic can generate a very high load on your application side. There's lots of ways of doing this through manipulation of the types of requests, manipulation of the type of connections, and essentially what you're trying to do is for a very small request, generate a very high load either on the network or the CPU, or maybe something really specific to the application if there's a vulnerability in the application that will consume a large amount of resources on the application server. And by doing this with a relatively small number of attacking hosts, you can consume all the resources in the server pool. And then there's other ones that are synchronous or essentially brute force and just trying to consume all of your bandwidth on your WAN link or all of your CPU on your server pool. And they rely on brute force and just the mass scale of the connections. So a lot of things we're looking at today will be most effective in those kind of simpler brute force kind of scenarios when we talk about DDoS. But again, it really depends on the specifics of how early you pick up the attack, how the attack is being played out, and how the botnet is being controlled and operated. And again, there's huge variability there. So I'll try to talk about some of those specifics as we get into the details. Sorry, my slides aren't updating there. There we go. So the first kind of situation here is, imagining a situation where we have a denial of service being operated, and at some point we detect this when it's in motion, and we want to try to mitigate this. There's a number of things that come into play in this. So first of all, GSLB systems, like most systems, will generally include some kind of real-time blacklists that will prevent connections and lookups from malicious IPs, from known malicious IPs. Now, I'll talk about this in a minute, but given the nature of DNS, there's ways this can be circumvented, and it's not always going to be effective. And again, there's always new IPs being infected that might not be there as well. Most people have some kind of engagement and SLAs with their ISP. You can contact them and ask them to black hole the request, which basically means stop sending the requests to your IP address and essentially black hole it within their infrastructure, so it just dead ends. It doesn't ever get to your endpoint. But again, these can sometimes take hours to be executed or longer, depending on your ISP. They may not detect it. It may not be big enough for them to detect, or again, depending on their service levels and other things and the technique used, it might not be something that they're able to respond to for some time. So having any kind of ability to take some kind of mitigating action yourself could save you a lot of time and could help mitigate the scope and severity of this incident rather than relying on your ISP's response. So one of the things that you can set up with GSLB is to return a poisoned response. So basically a response that is not valid, and in particular the broadcast IP is effective. Obviously you don't want to give back someone else's IP and just deflect the attack to someone else, but you can give this poison response, and as new nodes try to join in the attack, and as they try to look up that namespace, they won't be able to resolve the IP address and attack. So let's just kind of break down some of those details and some of those points and talk about them a little bit more specifically. So when we talk about the real-time blacklists and where they're effective and where they're not, when we talk about the source IP of a GSLB or a DNS lookup, it's very different from when we talk about the source IP of an application connection because of the nature of DNS. So when either a legitimate user or a malicious user does a lookup, if they do a lookup directly against the GSLB device from that system, it will be able to see their IP address and respond accordingly. So it will be able to see that that lookup is from a malicious IP, and it won't allow that to go through. But if they use an intermediary DNS system like OpenDNS or Google DNS or an internal DNS server in a compromised LAN, anything like that, and that's doing recursive lookups, well, in that case, the GSLB device will actually see the IP address of the DNS server in the middle rather than the actual client requesting that. So that means that we're not able to match those. So again, everything is about layers and layers of defense, and it depends very specifically on how the botnet is programmed to operate and how it's doing its lookups. So then again, let's look at how those poison responses work. And again, the difference between the attacking IP and the resolving IP is really important here, again, to understand the limitations of this technique and where it's effective and where it might not be appropriate. So often when we look at particular attacks, they tend to originate in particular geographical locations. Again, this isn't always true. Some can be very dispersed, but a lot of botnets have some kind of, or at least attacks have some kind of geographical concentration. Obviously, if you're a very global organization, it's your public facing website or e-commerce platform or something like this, cutting off an entire country or region might not be viable. But for a lot of people, they're operating, again, within some kind of localized region. And again, if you're an e-commerce site, depending on your PCI DSS compliance and other things, you might actually need to geofence connections and so on around your locale that you're authorized to transact with. So in the situation where you have this localized attack or this attack within certain specific regions, or at least majority region, and most of your legitimate users are coming from a different region, it's very easy to set up specific resolutions based on the geographical location, and you are able to poison the responses in those attacking kind of countries or regions and prevent them from properly resolving the FQDN. This will still allow users from other locales to get the legitimate IP address and connect to your application. Again, the thing to really understand here is that depending on the lookups, you won't just be poisoning the botnet source IPs, you'll be poisoning any kind of DNS servers within that locale as well for legitimate users. Likewise, let's say the attack is coming from a particular country, and then that botnet is using something like Google DNS that all resides within the US. That will all look like US originated requests via Google DNS to the GSLB. So there are limitations to this, but again, it's just one more thing to keep in mind, and it gives you a lot of flexibility to segment the traffic and the resolution of those malicious requests from your legitimate users. And again, this can be used, as I mentioned, with kind of e-commerce, even outside of attacks. This same kind of technique can be used to set up a fairly simple and crude geofencing kind of situation, which can also be useful. So the next situation I want to look at is when you have an active intruder, that intruder's been detected, and then what do you do next? Again, no matter how effective you and your organization are and all the best efforts, eventually we're all going to be compromised. If you are really forceful in your response and shut down the infected host, give any kind of indication that you've discovered the intruder, often they have multiple points of entry. You don't yet know if that's the only host that they've compromised. And all you're really doing is signaling to that attacker that they're there, and they're going to be much more cautious, cover their tracks, and possibly even destroy systems or data, and then just move out of your line of sight. So honeypots are a really effective technique. Things like Open Canary is a kind of open source one, but there's lots of these, both commercial and open source. This is a technique of setting up a system deliberately to be compromised, something that looks very valuable, again, like an authentication system or a large kind of source of sensitive data that will attract the intruder into attacking it and moving onto it, where you can control them, you have visibility and insight on them, and you can contain them there away from legitimate systems. So one of the things, once you have a honeypot set up and you know that an intruder is present, you need ways of directing them to that honeypot and trying to ensure that they land there rather than somewhere else. Again, there's kind of a number of techniques around this that can all work together, but GSLB can, again, be an important tool here by allowing you to poison the DNS responses to that breached system and ensure they always resolve to the honeypot. So what this looks like is, once we've been notified or detected that a particular host is compromised, in this case in the DMZ, we see that that host is compromised, and then on the right-hand side within our LAN, we see that we have an internal service on 1.2.3.4, and we have a honeypot in 5.6.7 of 8 that's contained. What we want to do is ensure that the attacker lands on the honeypot and doesn't discover that internal service that could be sensitive. So once we understand the situation, we can ensure that any lookups from that DMZ host via the GSLB for those other namespaces resolve to the honeypot IP address, so that as they're doing lateral movement and discovery and trying to look for other systems that they can reach, they're going to attempt to connect to the honeypot IP. And again, honeypots are generally set up with some easy to find but not kind of too obvious vulnerabilities that allow them to be compromised, again, to kind of entice the intruder to move ahead and kind of move onto that system. So in this case, what we're really doing is using the GSLB to ensure that the intruder is doing any kind of DNS lookup or any kind of discovery, is constantly pushing them to that honeypot and trying to increase the chances that we get them to move into that system rather than into legitimate situations. So just before we move on to the deployment risk, we'll just kind of quickly recap some of the main things around those security response. In both the DDoS situation and the kind of active intruder situation, the way GSLB is leveraged is really around identifying legitimate locations or legitimate sources, DNS requests, and segmenting them from malicious sources. And again, using various techniques and scheduling methods and persistence methods to poison the responses that malicious lookups receive. In the case of DDoS, we're using it to provide a complete dead end, a black hole resolution to the broadcast IP. In the case of an active intruder and the honeypot situation, we're giving them a legitimate IP, but to a honeypot system, or again, a kind of sacrificial system where we want to direct them. In both cases, the technique is essentially the same. It uses the same kind of technologies and the same methods, but we're achieving a different outcome with it. And again, in both cases, it's not always going to be viable. It's not always going to be something you either have the time or the opportunity to use, but it does give you another technique and methodology for controlling those malicious requests and trying to limit the severity and scope of those incidents. So now when we talk about deployment risk, again, often with deployment risk, there's a lot of focus on availability. There's a lot of focus from application and NetOps teams on how they ensure uptime and how they ensure stability in the system. But deployments are also a security risk. There's a lot of opportunity to introduce new vulnerabilities, primarily through inadvertent configuration changes that have some kind of security impact. And having alignment between the security aspects and the security team and the application and network teams can really pay a lot of benefits to both sides of that. And I just want to talk a little bit more about how GSLB can use to introduce more control around deployments and how that can be leveraged to have more robust kind of validation around security requirements without compromising performance or availability, as well as allow a quick rollback without compromising availability if security-related concerns require it. So again, it's really about collaboration across those different teams and showing you how a security aspect can be brought into that. So before we get into the GSLB side, which operates at the site level, I just want to kind of go through how controlled deployments and sort of common patterns look at a server level and application level that might be more familiar to people. And then we'll zoom out and show how that can be leveraged at a site level with GSLB. So when we look at a lot of modern techniques around deployments, again, often these have come in under some kind of DevOps transformation or DevOps focus as application teams have matured and increased their velocity. There's been all of these new kind of deployment patterns and techniques brought into play. This is really a process-related thing. While technology can automate it and control it, the key insight here is defining any kind of progress for the organization, accepting that any kind of progress requires a change, and that every change needs to be treated as its own deployment. And that every deployment then brings risks to availability and security. The traditional kind of mentality is because changes are risky, because deployments are risky, we should reduce the number of them. And this is where you get large, biannual updates with huge amounts of change, a lot of risk, and any kind of problems are very hard to isolate. The key insight that drives most modern practices is that by doing very frequent, rapid, and small changes, if anything goes wrong, the change is very small, easy to isolate, and easy to roll back. So everything is about speeding up the rate of change, but containing that change to very, very small increments. So when we look at a server level, and we talk about a blue-green pattern, or sometimes it's also called red-black. Here we have in the diagram just a user connecting to an application via a load balancer. There's a server pool, there's multiple servers there, and the application's on version 1.0. As this builds out, what we do with a blue-green pattern is, rather than do any kind of in-place update, we build out another server pool with version 1.1 of the application. And then we switch users via the load balancer over to the new version. And we just shut down or pause, or just kind of prevent users from being directed to the v1.0 server pool. Any kind of problems, whether it's availability, performance, feature sets, security, whatever they are, any kind of problems, it's very easy just to bring that version back online, switch users back over to it, and remove the new version from distribution while you investigate offline what the problem might be. If we look at a canary deployment pattern, it's a little bit different, and this is really about partial upgrades within a server pool. So blue-green's very binary. We have both old and new server pools. With Canary, we do it on a kind of per server basis, and we start to split traffic across both old and new application versions simultaneously. So in this case, we're just going to upgrade one server to the new version. If everything seems fine, we keep increasing the percentage of the pool or the users that are distributed to the new version. And again, if anything goes wrong, we can easily reverse that upgrade and reverse that change. Canary deployments do have a little bit more significance and require certain things of the application. Obviously, that it can kind of run multiple versions side by side, and you can't have kind of database schema updates and all those kind of things that might conflict. But where Canary deployments are really useful for application teams in particular are to run A/B tests. So to see users kind of have two versions of the system side by side and which one's more effective. That could be for feature testing, but it could also be for performance and seeing which version of the application or the service is more performant. In both cases with Canary and blue-green patterns, what you're really doing is limiting the risk by making changes to part of your application and always having an older version of that application to immediately fall back to either as a complete server pool or individual servers. So you can imagine all kinds of changes that can be happening at the application, the server level here, that would have a security impact. Renewing or changing server certificates, potentially changing authentication providers or authentication mechanisms, maybe upgrading part of the base, if it's a web application, for example, the base web server stack, which might have some known vulnerabilities. Likewise, if there are security issues that need to be rolled out, you know that that's going to bring with it some kind of availability risk, and that could have a lot of resistance, and people might not want to roll out security patches or security fixes as fast as a security team wants because of the risk to availability. If you have these controlled processes in place, it allows you to push for more aggressive changes in terms of patching systems and changing insecure configurations, because you can protect availability while you do this. So there's two sides of the coin there for security teams, both allowing them to test and validate changes, on a small scope of servers or pools, and monitor for changes and new vulnerabilities, but also to be more aggressive about having teams roll out requested fixes by the security team in a way that is much lower risk and allow faster response times. So this is all at the server level. This is all using a traditional load balancer. This does require certain things from the application. It requires certain things from your application team or networks op team to have multiple servers, multiple staged processes. If you're at that level and you have CI/CD pipelines, you have test environments, staging environments, production environments, that's fantastic. If you have applications that are fairly stateless and easy to do in this way, that's great. But GSLB can provide a kind of alternative that sometimes it can work hand in hand with the site level, but sometimes it's easier to implement because it has less requirements around certain application behavior and less sophisticated environment setup. So the same patterns can be used at a site level that you use at a server level. So with GSLB, rather than have a pool of servers, you have a pool of sites. This could be cloud and on-prem, it could be multi-cloud, it could be multiple environments at one site that just have their own public IPs and entry points. There's lots of ways that you could employ this technique, but at the very least, you could have a small test site and your production site, or your production and your DR site. And as a security team, you could try to promote that changes were made, on a site-by-site basis, and with some delay there that allows you to do proper audits and checks before things roll into production to ensure that changes are valid. So to see what that looks like at a site level, here we have 2 cloud locations and a on-prem or data center location. And in this case, we're imagining that each one of these upgrades behind this, there's a server load balancer and a whole pool. We've updated the whole pool. We now have just the on-prem location at version 1.1, while the rest of the locations at the original version. Again, following that sort of canary pattern or blue-green pattern, you can mix and match those, but you can do rolling updates site by site, use GSLB to determine which sites users are sent to, or even a percentage of users. And if anything happens, again, take users off those sites and start rolling them back to get back to full production. So GSLB, because it's so lightweight and it works at a DNS level, it's often much easier to get implemented and to make changes to than server load balancing does, and in particular because it doesn't sit in line with the application traffic. It has slightly less complexity around changes, and it could be easier, again, in simpler situations where you don't have huge amount of sites and resources and multiple environments to play with, to get something like this in play that gives you most of the benefits of those deployment patterns with a little bit less effort, a little bit less internal kind of politics and resistance from your application and network teams. Likewise, for those network and application teams, this is a way that you could meet even the most stringent kind of security requirements in a very controlled way, and ensure that your security team has time to audit changes you're making without kind of holding up your progression or risking your availability. So that's the bulk of it for today. We'll just do a quick summary and wrap up, and then get into any questions that have kind of on people's mind. So when we talk about both security response and deployment risk, operating at the DNS level with GSLB gives you this dynamic DNS resolution and this rule-based DNS resolution that can allow you a lot of control over where both legitimate and malicious users or lookups are being served and being sent. This is something that you can do in real time on the fly, as well as in automated, predefined ways within the scheduling and persistent rules. And it's something that I think is not commonly understood or commonly leveraged. And there's a lot of benefits for people looking again at simple techniques that can have a big impact, this is something else to make sure you have in your playbook. I have a lot more kind of practical guidance and detail around these kind of scenarios and others in my book, as well as a lot of things looking at team collaboration, transforming your processes and teams, looking at how, again, particularly cross-team collaboration works and how to manage that. So this is just a few of the kind of simpler situations today that I hope have been useful. But yeah, thanks so much for everyone's time. And Andrew, I'll kind of jump over and see if we got any questions. I can see one, I think, in the console already.
Yeah, thanks, Ben, for the great content. So yeah, we've had a couple of questions come in. So the first one has come in: is the use of security technology always safe for every data? Because there will always be data sticking and becoming an idol in every use of technology-based security.
Yeah, so that's a good question, Arthur. I think data is always, when you're talking about, particularly about dynamic switching, again at the server level or particularly at the site level, the replication time and the lag in data versus requests is always something to consider. It's particularly important in those scenarios where I just talked about the deployment patterns and kind of updating and rolling back sites. So as an example, something that was very data heavy, very stateful, for example, Microsoft Exchange. If you were doing that, even in an active passive scenario, you failed over to the passive site, there could be a lag in mailbox data in the database there. You would not want to switch back from that DR site to that active site until you were sure that any database replication and the state of the database was consistent. And you can have this kind of situation in both commercial off-the-shelf and custom applications, where you need to really work with your application teams to understand if the application or under what situations the application will be able to cope with that, and what are the kind of safety rails around database replication. But you're correct to say it is a constraint, and it's something that you need to be aware of in making those decisions if those techniques are appropriate.
So we have a couple more. So another question we got in: how does GLSB differ from DNS load balancing?
Actually, okay, so that's a good one. And it's sort of a common thing. So when we talk about DNS load balancing, and again, sometimes there's different terms used in different places, so I'll just elaborate a bit. DNS load balancing or similar terms really refers to when you just have multiple A records for an FQDN. The DNS server will respond with all of those records to the requester, and then it's really up to the requester kind of application to decide which one of those IPs it uses. So in this case, you don't have any control over the scheduling, so how traffic is distributed across those different IP addresses, and you also don't have any persistence. So on new lookups, the same user could be sent to different sites, different locations. Again, that would potentially be an issue like Arthur kind of raised around data, and their shopping cart is suddenly empty because they got sent to another location and that data isn't replicated. And you also don't have health checking. So the DNS server will continue to provide all of those IPs to requesters, even if one of those sites is down or not functioning correctly or overloaded. And again, that would require you to manually go in, edit those records, and remove that IP address, which I'm sure everyone's familiar with. So GSLB essentially gives you all of those capabilities dynamically, automatically, and in real time, and gives you much, much more control than just multiple A-record responses does.
Thanks, Ben. And another one here. Are there special needs for the application for GLSB to work?
In general, not. Again, your persistence and scheduling is important to understand the data replication, the statefulness that we already talked about. There are some, essentially it needs to use DNS. So there may be particularly in-house applications or legacy applications where connections are hard-coded IPs within the client or maybe within the front end and back end services. If anything is working at an IP level and there's no FQDN, there's no DNS resolution involved, that wouldn't obviously be appropriate. But otherwise, again, that's a vanishingly small number of applications these days, but that's about it. It's quite generic and quite generally available to all applications.
And I think we'll take this final question before wrapping up. What would the DDoS mitigation you shared not work?
When would it not work?
Yeah.
So there'd be a couple of situations where this wouldn't work. We talked a little bit about where we have recursive lookups. If there was a lookup from say a large DNS provider and they didn't honor the time to live value, so often big provider, well not often, but some big providers, particularly ISPs, to reduce the load on their DNS servers, they will not honor the time to live value, so they won't expire the record, and they'll cache that for as long as they want, sometimes days. In that situation, if that provider already had the IP address to your application and all of the botnet nodes were using that to look it up, it would just give them that answer and not ask you for a new response. So in that case, it would just bypass any dynamic changes you made and prevent you from acting on that. Another situation, again, this depends on the botnet itself and how it's programmed. There are situations where the nodes in the net are looking to the controller for that resolution. So again, if the controller or one of the nodes resolved the IP address and then provided it to all of the nodes before they tried to connect, that wouldn't give you the opportunity to poison subsequent lookups, and that's a kind of known technique in some cases. And then the final one is really around not so much that it wouldn't work, but it might not be acceptable to your organization. Would be if the malicious kind of lookups and the legitimate lookups were coming from the same source. So again, if the botnet was using something fairly ubiquitous like Google DNS, and most of your legitimate users were also using that system, if you poisoned the response to Google DNS lookups, then that's going to poison the IP that Google provides to everybody. And so although it would definitely stop the botnet, it would stop everybody else as well. And that might not be, it's not viable, or you're not getting to the outcome and the impact that you intended in that case. Thanks,
Ben. Thanks for all the insight there on the questions. Yeah, so I think at this stage we can wrap up, and I'd like to thank Ben for taking the time today to provide his expertise on the topic. As I mentioned earlier, this webinar will be made on demand shortly, so you can come and check back if you'd like to review any of the content covered today. And also, if you would like to check out our website, we have a couple of different trial options if you're new to Kemp. And we recommend trying out our VLM trial. And also, as Ben mentioned, he has a AX book on Amazon that goes into a lot more detail on some of the topics he's covered today. Any final words, Ben, or?
No, I think that about covered it. Just, yeah, thanks to everyone for their time today, whether live or listening to the recording. And I hope it was worth your time and you got some ideas to take back to your teams and to think about.
Great. Okay. Thanks, Ben, and thanks everyone for joining us today. Bye-bye.
Thanks, Ed.